You've probably made scatter plots. You probably had to make them by hand. I know in Algebra 2 we did, and we would have to sort of give our best guess as to what the line of best fit was and pick a couple points and put a line in there and try to come up with that equation. Well, there's actually a best line of best fit, and our calculator is going to do that for us. And we're also going to make our scatter plots with our calculator. So most of the work that you're going to be doing is going to be done on the calculator, and so we're going to spend a big share of today's time doing that. But before we get there, I've got to talk about some other things so that we can kind of get on the same page as to why scatter plots are important and what to kind of look for. So first off, it's a bunch of ordered pairs. Okay, it's a bunch of points on a graph, and that we're going to use it to try to determine if there's a relationship between the two variables. Does one variable impact what happens to the other variable? And there's lots of different ways to look for that and test for that, and we're going to talk about some of them today. There's 4 types of possible relationships that we're going to look at, and on the next 4 screens, there's going to be some graphs and the descriptors for those types of relationships that as we get to each screen, just go ahead and take a picture of that and add it to your notes, and we'll talk about it a little bit. So the first one is a positive linear relationship. Okay, so go ahead and take a picture of that, and we'll talk a little bit about why it's 1, positive, and 2, why it's linear. First off, it's positive because the points seem to be going in an upward direction from left to right. Okay, it seems pretty clear, right? One of the ways to test for it is to surround the points with a boundary and see if you can fit a line to it. And to me, this looks pretty much like a straight line. Okay, something like that. So you want to test by doing a boundary around it and then see if it has direction. Now in this particular case, we could also describe it using the word strong or weak, and part of what we're going to be doing later on is to come up with a mathematical way to decide if it's strong or weak. But you can kind of make a prediction based on how close the points are, 1 together and 2 to that line. The closer and tighter those points are together and to that line that makes sort of a line formation, the stronger that relationship is going to be. So one of the things that not only are you going to use the word positive and linear to describe it, in this case we would probably say it was strong positive linear. And again, we're going to talk about a mathematical way to determine its strength here in a second. Okay, what do you think the next one's going to be? Negative linear. So what's going to be different about it? It's going to go down from left to right. So yeah, here's a negative linear relationship. Okay. And again, if I put a little boundary around the points, we would see that negative downward movement from left to right. We could put a line on it if we wanted to sort of cut through the points. That's probably not the best line you can make, but you get the idea. Okay. So there's 2 other kinds of relationships that we're going to talk about. One is a nonlinear relationship, or curved. As you can see, it starts off kind of linear, but then as you move further to the right, it starts shooting up quicker. This is going to be more of an exponential relationship. Okay. And if you remember dealing with exponential graphs, they always had that kind of curve to them. So a straight line wouldn't make sense here. It looks like it's got a curve. It's not linear. Okay. And then the last one is just no relationship. So when I try to put a boundary around those, it's just kind of a blob, right? The points don't seem to be going in any direction at all. And when that happens, we say that there is no relationship, which means there's the one variable doesn't really affect what happens with the second variable. Okay? So those are the four kinds of relationships we're going to talk about. Now we also need to talk about strength, okay, and how strong the relationship between the points or the variables is. And the way that we determine how strong or how weak the relationship is by using what's called the correlation coefficient. So here's some things we need to know about correlation coefficient. First off, we use the letter R to represent the correlation coefficient. It will be in between -1 and 1 inclusively, which means it can equal -1 or it can equal 1. It can't be bigger than 1, it can't be bigger than -1, it's always going to be in between there. And we're not going to actually do the calculation for R. Our calculator is going to do it for us. Okay? You're going to have to write down what the value is, but the calculator will do the work for you. Okay? And here's what's important in terms of strength, how strong the relationship is versus how weak the relationship is. Okay? The closer the values are to 1 or -1, the stronger the relationship, the stronger the correlation. What that means is, okay, for a positive relationship, if there's a very strong correlation, then the R value is going to be close to 1. If it's a negative relationship, the stronger the correlation, the closer to -1 it is. Which also means the closer the values are to 0, the weaker the correlation. So 0 is that sort of tipping point where we might still have a relationship, but the weaker it is, the more spread out the points are from each other, the closer R value is going to be to 0. With what we're doing here today and what we're going to do in our calculator, we'll want to round our decimals 3 places every time. Okay. So after we graph our scatter plot and we come up with our R value, we're gonna put the line of best fit on the scatter plot as well. And those things we're going to be taking pictures of. So you're going to do the work in the calculator, you're going to take a picture of it, and you're going to insert it in your homework. Okay. That line, that's the line of best fit, called the line of regression. And really what the line of regression is, okay, because like I said, in Algebra 2, the way I teach it is we try to fit the line that we see that we think is best, but we make sure it runs through a couple points so we can write an equation. There's actually a best line best fit, and that's called the line of regression, and we're going to find those values using our calculator. So on the next screen, I'm going to have the problem that we're going to work through together, and then the following slide after that is actually a video that I created that's attached to your assignment that I'm going to leave there that walks you through pretty quickly, because I did it with a class, of how to do all of this on the calculator. And so what's going to happen is I'm going to play it through the TV, and then I'm going to pause it and add to it as we're working through it, and I'm recording all of this so then it'll all be up so you can refer back to it later in case you forget at some point. Okay. So here's the problem we're going to work through. Go ahead and take a picture of that, put it in your notes, and then we'll start with the video and start getting all of this into our calculator. So here's what we're trying to figure out. Okay, we've got data that represents people's age in Pennsylvania and the number of car accidents that they got into based on their age for a certain period of time. And we're trying to see if age is a factor in the number of accidents. Okay, and just as a general, looking at it, you guys seem to have more accidents than people in college, for example. There could be lots of reasons for that. All right, experience could be a factor. When you go to college, sometimes you don't drive as much. But they want to see if there's a correlation. Okay, and so that's what we're going to do with our calculator. So here's the video that I made last year. okay? And forgive any screaming or anything like that, but I had a classroom full of kids and going through it and make sure we're all on the same page. Like I said, I will pause it as needed to explain anything that we need to, but everything that we're going to see here is going to be recorded, and everything that we do in here is going to be recorded. So that way you have it for a later time, okay? So here we go.
So the first thing I want you to do, I want you to access catalog, okay? So hit the second and then the 0 to get the catalog, and then you have this list. You need to scroll all the way down to diagnostic on.
I'm trying to find
and yeah, it's way down. So there's diagnostic off, diagnostic on, and then you hit enter, and then
okay.
And it will give you this screen that says diagnostic on. Hit enter again.
Okay. So after you do diagnostic on, you hit done. And the only time you would ever have to go back and do this again is if for some reason your calculator completely reset. Once we've done it, it shouldn't be an issue moving forward. If for some reason, and I'm going to explain here in the video why we need to do this, I'm going to explain that next, actually.
In the catalog, okay?
You should do it now.
What diagnostic on does is when we go to create the line of regression, and it gives us the slope and the y-intercept, it will also give us the R, the correlation coefficient, okay? If the diagnostic is off, it will not give us that. And if you watched the video, you saw that originally when we did it, you probably did not have an R, you just had an A and a B, and we'll talk about what all that is in a second.
So what that means, first off, I keep referring to this video. This class had to watch a video before showing up to class, so that doesn't apply to you guys. Second of all, if the diagnostic isn't on, it will only give you the slope and y-intercept, and it will not give you the correlation coefficient, okay? So when we get to the next, toward the end, where we find out the slope, the y-intercept, and the correlation coefficient, if for some reason the R doesn't show up on your screen, it's because your diagnostic is off, okay? We should all be good now because you've all done it and nobody seemed to have an issue with it, so we should be good.
Okay. So when we go to enter the data, we hit the stat button, okay, and we're going to edit.
So stat button, and then we're going to edit. We're do that number 1 there because that's where we're going to input all our data.
Stat is 2 to the right of the green key, okay? Now, in my list, I removed all the data. One of the things I want you to be careful of when you want to clear your list, do not use the delete button. Because if you press the delete button, you will literally delete the entire list.
So here's what that means, okay? So if you have any data in here, okay, and you hit the delete button up here, you'll lose L1 altogether. It'll be gone. And trying to get it back is not really nice. It takes a little bit of work. So what I'm going to show you is how to clear it and remove all the data without removing the actual list, okay? So essentially what's important is we're never deleting lists, we're clearing lists. You can certainly go through and one at a time remove each data point, but there's an easier way to do that.
If you want to, so if I'm going to enter the data 16, 17, 18, I'm just going to stop there because I'm going to show you how to delete the data. So I go up to where it says L1 and I highlight it, and then I hit the clear button. Do not hit delete. Clear, and then enter, and that will remove the entire data within the list.
So that makes it easier to clear an entire list out than doing it one at a time. Again, it's up to you. I'm not going to prohibit you from deleting it one at a time. But oftentimes you're going to have a lot of data in there, and it's just going to be a lot easier to clear all the data out.
Without eliminating the list. Yep. Yep. Yeah, you want to go all the way up to the top, to where it says L1. and then hit clear. Okay. Now, so let's enter the data and someone will have to read it to me. I know it's 16, 17.
Okay, so you guys have the data in front of you. So we'll use L1 for the age, and then L2 for the number of accidents. So go ahead and enter all of that in. Be careful when you enter data in too. Sometimes you'll transpose numbers or miss a number or something like that. If you don't enter your data in exactly the way it is, it will mess everything up for you.
18, 19, does it go to 21? So the data that was in the video. Okay. And then I move over to list 2. What's the rest of the data? Somebody read it to me. 6605 8932 8506 7349 6458 5974. Okay? So now,
Do all of you have the data in your calculator right now? Okay, good.
when I look at my data, I've got X, and my list 1 is going to be my X's, my list 2 is going to be my Y's. Okay? Is that data correct? Based off of what I had in the video?
So this is, I'm double checking right now.
Now,
Double checking that I entered it
Here's
right.
what happens with this. Okay, now that I have the data in there, I can turn the stat plot on, and it will produce a scatter plot.
So stat plot's
Now
there
I'm
right
gonna show
above
you
the
how to
y
do that,
equals.
Okay, so the stat plot button is right here. Okay, so I hit second, and I hit the y equals for my stat plot. Now look what comes up. Okay, I have 4 different possibilities, and if you notice, so they're all.
So on mine, when I did this, the stat plots are all off. It's possible that some of your stat plots are on, okay? And if they're already on, you might as well go in and use that one, okay? But if you have more than one on, you only want to have one on. So you're going to have to go in and turn one of them off. And you'll do it similarly to how I'm about to show you to turn one on, okay? So, yeah.
My plots are all off right now, so I'm gonna go ahead and hit enter on number 1 because I need to turn that plot on. And if you notice when I do that, it gives me all these different options.
So one of the things too, once you're in the plots, notice at the top I have plot 1, plot 2, plot 3. So if I was up at the top there, if I wanted to move the cursor up to the top, I could shift from plot 1 to plot 2 and that kind of thing. But if you have a plot already on, you just need to slide over to off and hit enter, and it will be off.
So first I need to hit enter to turn it on, and so now my plot is on. And then if you see here in the types, there's several different possibilities. I can do a scatter plot, and it looks like a little picture of a scatter plot, which is what I want. There's a little line graph. There's like a histogram bar graph. There are box and whisker plots, which we don't need. So we want, it's already on the scatter plot.
So if your scatter plot isn't highlighted on your graph right now, move your cursor over to it, hit enter to highlight it. That way it'll create a scatter plot for you.
So I'm good. I also want to go down and look at my X list and my Y list. So we put our X's in list 1, so that says L1, so we're good. Y list is L2. If you ever wanted to change those, down here are where your lists are. L1, L2, L3, L6, L5, L4. So you can tell the calculator which lists to pull the data from when you.
So here's what I mean there, okay? So right now I want my X coordinates to come from list 1. I want my Y coordinates to come from list 2. If for some reason you were entering more than 1 list or 2 lists of data, and you just wanted to keep adding to the list and do, I'm going to leave list 1 and 2 alone, and I'm going to add my next set of X's in list 3, you would just have to change this L1 to L3, and that key is above the number 3, okay? So if you ever were in a situation where you wanted to do that.
Are we gonna be doing that when we have like L3?
Not necessarily. You can do it if you want. Most of the time you can just clear the data out like I showed you at the beginning, and just enter new data in. But that's kind of up to you. You shouldn't have to. If once you're set up with L1, L2, you should be able just to clear that data out and start a new problem. Okay.
You do your graph, okay? And you can change the mark. So right now on the bottom.
And the mark is the symbol that shows up for the points, right? When we graph a notability or we graph on paper, we put a little point. And so that's an option. Okay, we have this little point over here, but honestly, it's hard to see. It doesn't show up as well. And then there's this little plus sign, and I'm going to talk about that here in a sec.
From here, my mark is like this little square thing. I can change it to plus signs if I want to. I can change it to just a point. I'm going to leave it as this sort of square thing because then it'll show up better. Now, the last thing I want to do before I actually go to graph is I want to hit the y equals button to see if there's any graphs already in there.
So one of the things that can happen is you're working on it, you're working in your calculator, doing something, maybe a different class or whatever, and you type an equation into the y equals screen, and you don't remove it. In our case, if it's still there, that's going to create an issue for us seeing our scatter plot properly. So this is what we're doing now, is just making sure that we don't have anything in the y equals screen that we shouldn't have.
And in my case, and you want to scroll down because sometimes you'll have junk in there that you don't need. All right, and I do not have anything on my y equals screen, which means there will be no other lines.
So if you do have something in there already, you just want to clear that out of there. Okay, clear that old equation out of there, and then that way we have a fresh graph that we're going to work with for our scatter plot. Okay.
We're good to go there, okay? And notice that the plot, number 1 at the top is highlighted, which means it's turned on. So now if I hit the graph button, it should show up. Except here's what my problem is. My window is set up as a 10 by 10.
So here's what I mean by that, a 10 by 10. That means to the right, it only goes to 10. To the top, it only goes to 10. To the bottom, it only goes to -10, and to the left, it only goes to -10. Now, if you had been playing in your graphing calculator some other time, your window might be different than my 10 by 10, okay? And that's okay, but it's still unlikely that your scatter plot is showing up. So I'm going to talk about how to deal with that.
And if we think about our data, the lowest x value is 16, the highest x value is 21, and all my y values were in the thousands. So my window doesn't even show where the data would be.
So what I'm saying is the data is all bigger than 10. So this window is not big enough to potentially show our scatter plot. Our scatter plot is probably going to be, our points are going to be way up here somewhere, right, if I extend this out. So our calculator has an option for us to make it easier to see the data. Bless you.
But our calculator can zoom in on our plot. And so if you scroll down, there's a bunch of different zoom options, but number 9 is zoom stat.
So you hit the zoom button, which is the middle button on the top, scroll down to zoom stat or zoom statistics, and our calculator knows where to zoom into. We don't have to choose the window for it. Our calculator will do it for us. Yep.
Which means it will zoom in on where my statistics are. So if I hit enter on number 9, now it'll just show me my my scatter plot.
So what's nice about this is once you enter all the data in, it will give you that. Now, for your homework, I'm going to give you 2 options. One, you could take a picture of this now, but eventually we're going to put the linear regression line in there too. So what I recommend is waiting until we put that line into the graph as well, and then take a picture of that whole thing and insert that into your homework or notes, okay? And we're going to work through that next.
Okay? And if you hit the trace button, okay, now it's going to jump from point to point.
So here's what I'm doing with the trace button, okay? So notice, it's where I pause it isn't the best, but there's this like little, on your screen you can see it, there's like a little flashing cursor right here, okay? And so what it's telling me is the exact coordinates of that point. X is 16, Y is 6,605, Okay, so if you're, again, I'm double checking to make sure it actually graphed the points that I needed it to graph. And then you can move around from point to point.
There's one of my points, 16, 6,605. If I hit the right arrow, it'll jump over to the next one. And so I can keep moving around from point to point to make sure it's actually graphed the points I want. Okay, so that's kind of a cool little feature. Okay, now, the next thing. First of all, are there any questions so far? Okay, now, part of the point of 2.4 and part of the point of what we're doing for displays of data is to find a correlation between these points to see if there's a relationship. Okay, it appears like, except for this point over here, we have a fairly strong negative relationship, because as it goes downward from left to right, that makes it negative. And as
So, going back to that, if I look at these points, if I were to sort of fit a line on there, it would probably look like that-ish, right? But because of this point over here, it's probably going to pull this line down a little bit, okay? And we'll talk about that in a second.
talked about in the notes, the stronger the relationship, the closer to 1 or -1 it will be. And since this one seems to have a downward negative relationship, we would expect that the R value is going to be closer to -1 than it will be to 0. But because of this point over here and the fact that we only have, 6 data points, it's likely that's not going to be close to -1 because of this point over here. All right, but we'll see and we'll test it out. Now, the next thing that we want to do is we want to find out the values of R and the slope and y-intercept for my line of regression. So I hit my stat button again, and this time we're going to go over to calculate. And you can use number 4 linear regression, it's AX plus B. You can also use number 8 linear regression.
So it doesn't matter which one you use. They both are linear regression lines. The difference between 4 and 8 is where the y-intercept is and the slope is, right? So the slope is always right next to the x. The y-intercept is without the x. Down here, A is the y-intercept and B is the slope. I think in my example I use 8, but you can use 4. But what you're going to have to do in your homework is you're going to have to write down what the slope is anyway. And I don't want you to write A or B. I want you to write M. Slope is M. Right, we know that because we're gonna be converting this into slope-intercept form, y equals mx plus b. So just know that you want your y-intercept and your slope, that you're gonna write those down for your homework. Okay.
And that's A plus bx. The only difference between the two is in number 8, the y-intercept is A, but in number 4, the y-intercept is B. It doesn't matter which one you use. It will still do the calculations for you. I'm going to use number 8 because that's what I talked about in the video. And so from there, I just hit enter. Okay, now your screens might look different, but you want to double check that your X list is.
Depending on what version calculator you have, this might end up looking a little bit different, okay? But it should still contain the same information, okay? If it looks a little bit different, that's okay. But it, like I said, it should contain the same information. The lists are what's the most important.
List 1, your Y list is list 1. We don't need to do anything with the frequency list or the storing the regression equation. Actually, we might be able to do that, but I'm going to leave that off for now because I'm not entirely sure how to do that, but I feel like that's probably useful. But anyway, once I hit calculate and hit enter, it's going to give me all the values that I need. And this is something you need to know how to do for your quiz. This is something you're going to need to know how to do for your test. What I mentioned in the video is that in this case, B is my slope, negative 335.257. And then the A, or the y-intercept, is 13,506.257. You want to write those down somewhere, especially because on your tests and quizzes, you're going to have to tell me what those values are.
Okay, so again, it will give me an equation up here. So if you use number 4 instead of number 8 on that stat calculate screen, this will be AX plus B, which will reverse those numbers. So again, the slope is always with the X. So just make sure you write that down. And when you do your problems, you're gonna need to write those down. You're gonna need to write it down for two reasons. One, so I can see that you know what you're doing. And two, we're gonna enter those values into the y equals screen to draw our line of regression on the scatter plot. Okay?
You said 3 places though?
3 places, yeah. We're gonna round our slope, we're gonna round our y-intercept, we're gonna round r to 3 places every time.
Okay, and then same with r. R squared is just r, this correlation coefficient squared. We don't really use that for anything, but we will use this r. And as we mentioned before, because of that outlier, it's not as close to -1 as we would have expected. But these are the values that you need to write down for your homework assignments, for your quizzes, for your tests.
So the only thing you don't need to write down on this screen is r squared. Let me be clear. Taking a picture of this screen, I do not want you to do. Okay, I want you to actually physically write those numbers down. I don't need the r squared. I need the r. I need the slope. I need the y-intercept. Okay?
In order to come up with the correct answer. So now I need to write these numbers down so then we can then turn it around and put it on my y equals screen, and then I can insert the linear.
This is me stalling because I'm writing the numbers down.
Linear regression line, the best fit line.
All the stuttering and
onto
stammering,
my
I'm writing the
scatter
numbers
plot.
down and trying to keep
So I'm
talking.
going to go over and do that now. Okay. So on my y equals, my slope was -335.257, and then I'm going to put my x in there because that's the slope.
So the x, right here, this button next to the green button, that's where I got the x from. You hit that, and that's where the x will show up. Okay? So again, I put my slope with the x.
Plus my y-intercept is 13,506.257.
Let's think for a minute what the y-intercept is too, by the way, why that number is so high. Okay? The y-intercept is always when x equals 0. So in this scenario, which I realize what I'm about to say is an impossibility, but if you were 0 years old, they would expect you to get into 13,506 accidents, right? Which I suppose makes sense. If we put a baby behind the wheel somehow and let them drive, you know, they're probably going to crash a lot. So that's why that number is so big.
Once that's in there, what we should see is the line appear on our scatter plot and sort of cut it as best as we can
You just
down
have
the
to hit
middle.
the graph button now, and
So
it'll
notice
graph.
here that because of this point here, it sort of tilts the line down instead of being really right over the point. This point pulls the line down.
So this goes back to when I drew that blue line up there a little while ago. You know, we sort of expected a line here, but because of this point, it pulled it downward. Okay. How many of you were able to get that to show up on your graph? Okay, good. So this is what I want you to take a picture of. Once you have the scatter plot done, once you have the line in there, then you're good to go.
So we have to go through all of those steps.
Yep.
So for this set of data, that's the line of regression. Okay, and so that's what we're doing in this section.
So, yes, you have to do all of that. However, this was for some of you, this is your first time doing it. Once you do it 3 or 4 times, it gets pretty easy. Because once you remember that I go to stat, edit my lists, zoom stat, then it'll show me my scatter plot, do my stat calculation, and then you've come up with your linear regression. It will give you all the values you need. You type those in, put them in your y equals screen, boom. Once you do it a few more times, it'll go a lot quicker. Okay? So let me just say that again. If for some reason the diagnostic gets turned off, you don't have to go through and turn it on every time. But if for some reason it gets turned off, on the screen after we do the calculation for linear regression, how you'll know the diagnostic is off is the r squared won't be there and the r won't be there. So you just go back to catalog, turn diagnostic back on, and then go back to the linear regression calculation, and it'll give you the R values.